everybody else seems to be doing it one way, there might be more opportunities the other way. A very good morning to all the excellencies, distinguished delegates, ladies and gentlemen, and all the students. I, Namita Soni, feel privileged to welcome you all to AICTE ATAL sponsored Faculty Development Program on Industrial Internet of Things IIoT on behalf of Department of Mechanical Engineering, Swami Keshwanand Institute of Technology, Management and Gramothan. I heartily welcome all the dignitaries, HODs and faculty members who are connected with us through this digital platform. In the current age of information technology, the Industrial Internet of Things IIoT has emerged as a popular extension of the Internet of Things in industrial sectors and applications. It has a strong focus on machine-to-machine communication, big data, and machine learning, which enables organizations, industries, and enterprises to have increased efficiency, coordination, and reliability in their operations. The FDP targets to acquaint the participants with the understanding and scope of the IIoT, which encompasses industrial applications including robotics, production processes, and cyber physical systems. Now, I would like to take an honor to call Dr. Ramesh Kumar Pachar, Principal SKIT, to please grace the audience via worthy words. Over to you, sir.
Thank you, Namita ji. Very good morning to all of you. It's a great pleasure and privilege for me to welcome today's chief guest, Professor Asim Tiwari, Department of Mechanical Engineering at Mumbai. He has been kind enough and agreed to join this program on a very short notice. Thanks for that, sir. He has a very rich experience in academia and industry, and that is surely going to benefit all of us during his deliberation. So once again, welcome you, sir. Next, I am equally privileged to welcome eminent speakers and guests who have joined this session and are going to contribute in this ATAL FDP on Industrial Internet of Things in coming days. On this occasion, I also take the opportunity to welcome our Director Jaipalji, Head of Department Mechanical Engineering, Dr. Dheeraj Joshi, members of the organizing team, other head of departments, faculty members from other departments, and the members of organizing team. I would like to extend a special welcome to participants, faculty from various esteemed institutes who have joined this ATAL FDP. So once again, I welcome you all in this inaugural session. And next, I would like to share a few words about our institute. So the Swami Keshwanand Institute of Technology, Management and Gramothan, popularly known as SKIT, was established in the year 2000. Institute has secured highest marks in Quality Index Value System, a practice introduced by RQ Kota in year 2017 for grading the quality of education of its affiliated institutes. SKIT is ranked first consecutively for the fourth time in this grading system. The engineering departments of SKIT are accredited in continuation by National Board of Accreditation, New Delhi, from year 2009 onwards. To share with you about our NPTEL SWAM local chapter, in past quarter, the institute faculty and students has performed exceptionally well in these courses. 12 faculty members topped the course, while 11 members received gold certificates, and a result among 4,000 local chapters, the institutes achieved third position in the special category of best faculty participation. Next, to share information among its stakeholders, the institute has its own in-house developed ERP system, and the institute also publishes SKIT Research Journal biannually since year 2011. I would also like to share that in addition to existing UG, PG and PhD programs in engineering, we also run a PG program in management. And from last academic session, we have added a UG course in computer science and engineering with artificial intelligence stream. And we are also in process of introducing another new UG course in data sciences from this academic session 21-22. Seeing COVID-19, Institute has developed 3 state-of-art digital studios to support online teaching and recording facilities. So in addition to live online classes, we have also developed standard e-content separately for most of the courses with the help of these digital studios. These courses are made available to students digitally via our in-house ERP system. During this academic session, more than 70 online programs has been conducted by various departments of the institute. Now coming towards our social responsibilities, to groom our students as good citizens, we lay a great emphasis on the value education and on our social responsibilities. Related activities are given a lot of importance while designing the yearly induction program for the students. The institute regularly organizes social activities related to village upliftments in nearby areas. We have also received appreciation from Honorable Governor of Rajasthan State and State Health Department regarding organization of regular blood donation camps for last 20 years, where a large number of voluntary donors donate their blood. Apart from this, we have also taken several steps to make our campus eco-friendly and environmentally sustainable. One of the major steps is that we have installed a solar PV system of 900 kilowatt capacity, which makes SKIT almost a net zero campus on the basis of energy consumption. The institutional building has also been awarded with first prize by Department of Energy, Government of Rajasthan for the same. The institute is also making serious efforts in the area of conservation of water. So these were few words about SKIT. I once again congratulate the head of department, mechanical engineering and their team. And I'm sure this ATAL FDP on industrial Internet of Things is going to be a great success. And finally, my best wishes to all the participants and sincere thanks to the experts who are going to deliberate in coming days. Thank you. Over to program host.
Sir, now I would like to request Dr. Dheeraj Joshi, Head Department of Mechanical Engineering and also the coordinator of this FDP program, to present a brief outline of FDP. Over to you, sir.
Yeah, thank you, Ms. Namita. A very good morning to all present in the virtual session of this FDP. I, Dheeraj Joshi, as a coordinator of this FDP and as the head of the department, takes my utmost pleasure to welcome our esteemed guest, Professor Asim Tiwari, as chief guest. Welcome, sir. And as our principal has rightly said, on the short notice, on a simple phone call, he has agreed on our request. This proves his generosity and the dedication for the professional accomplishments. So I would also like to welcome our principal, sir, who is online, and he has always been an instrumental and a driving force in motivating us in making the things in shape, be it academic or be it professional. So we welcome him, and we are also privileged to have our whole management. Although I'm just waiting, let me see. Our director, sir, is also a very vibrant and motivating force behind all these activities. So in his absentia, I welcome our director, sir, also, and a whole management of SKIT, who has been always supporting for making these types of show a real success. So again, the most important of every FDP, or the backbone of every FDPs, are the participants. So I welcome all the participants who have joined from different parts of the country to get benefited by this particular FDP, and especially this inaugural session by Professor Asim Tiwari, who is going to present a recipe. We are going to taste the recipe of the Internet of Things. I'm sure the most of the participants are from various fields, not only from mechanical, but mostly are from computer science and electronics and electrical area. So let me just focus in a few lines that already Ms. Namita has said that Industrial Internet of Things has emerged as a popular extension of IoT. But speaking frankly, IoT has a broad spectrum, but we as organizers of this FDP from mechanical engineering background have just focused on the industrial sectors and applications of IoT. It's a subset of IoT. We should say IoT is at the convenience and ease of the customer rather, but IIoT, that is industrial IoT, will focus on the efficiency, coordination, reliability in the organizations, and increasing the productivity of business houses. So I'm sure with the long list of invited speakers from different NITs and IITs, we are going to achieve our target, that is to acquaint the participants with the basics of the IoT spectrum. And I hope with the attending this 5-day FDP, they will be able to hone their skills and will able to apply their knowledge and the fruitful takeaways from this FDP to their respective institutions and research areas. So we will be having 15 sessions, 14 technical sessions, as we have also mentioned in the brochure. And the participants will definitely be benefited by a number of sessions, including the smart manufacturing, IoT hardware, Industry 4.0. If cyber physical system is a good recent buzz in the market these days, machine learning, AI in manufacturing, so role of big data. So there are a lot of sessions, and if you have a consideration to the brochure, we will see that we have tried to incorporate all the major research areas or the thrust areas in the IIoT. And we hope that with the adequate knowledge and experience from the lot of experts from different academia and industry as well, we will be able to touch the objectives of the FDP well. So without wasting much time, I am delighted to say that we have our esteemed guest, Professor Tiwari, whose profile I request Namita ma'am to just share with the participants so that they can be motivated in their own organizations to work on these areas of IoT. So thank you once again to all the participants, all the I would remiss my duty if I do not thank the AICT and ATAL, the scheme which has helped us to make this FDP in this shape. So financially and as well as academically. So we are thankful to the AICT and their officials for this grant. And I hope we will be having a very rich and enriching experience in the coming times. And over to the host, Ms. Namita, for the other things in the FDP. Go on.
Thank you, sir. Now, before proceeding further, I request all the panelists to kindly on their camera for group picture. Hello, everyone. We are extremely honored to have with us Professor Asim Tiwari, Department of Mechanical Engineering, IIT Bombay. Dr. Asim Tiwari is a professor in the Department of Mechanical Engineering and the Center for Machine Intelligence and Data Science at the Institute of Technology, Bombay, Mumbai. Prior to this, he was a staff researcher at General Motors Global R&D Center in Bangalore. He graduated with a BTech degree from IIT Kanpur, followed by an MS and PhD from Georgia Institute of Technology, Atlanta, USA. After his doctorate, he was briefly with the National Aerospace Laboratories, Bangalore. Subsequently, he joined IIT Kanpur, where he served as an assistant professor before joining General Motors Global R&D Center in Bangalore. At IIT Bombay, he has been instrumental in setting up various research centers and several advanced state-of-the-art facilities. He has over 100 international research journal and conference publications and 10 international and 4 Indian patents. Over the last decades, his group has secured research funding of over 100 crores of various governmental and industrial projects. Among various other activities, he has established a cyber physical systems and data analytics research group at IIT Bombay. The group works in smart manufacturing, machine learning, data analytics, and IoT for various sectors including manufacturing, transportation, and defense. The group has developed end-to-end solutions for digital factories and indigenous industrial IoT devices, along with the cloud networking and data analytics backend. The group is also involved in video comprehension based on deep learning for inference and surveillance. The group offers executive training courses on machine learning and deep learning to the industry and has many industry projects of its credit. Now, I would like to request our chief guest, Professor Asim Tiwari, to kindly acknowledge the audience by sharing your experience and knowledge on the topic IoT and artificial intelligence, a recipe for the next industrial revolution. Over to you, sir.
Well, thank you very much for that generous introduction, and thank you to Professor Joshi and Mr. Principal for inviting me for this occasion. And I do understand that the audience is a mixed audience. It's not just the audience which is from mechanical background, but is also from electrical and computer science background. And thus I feel what I will be sharing today would be something which could resonate to a much larger audience. And thus it would be of a more generic nature. So it would not be going into those many specific aspects of the technology, but the much bigger or the larger picture of the technology. So I hope my screen is visible to everyone. So this is basically a topic which has been active for almost, I would say, about half a decade, about 4 to 5 years. This Internet of Things and Internet of Everything has been very popular. So I'll be giving you firstly a quick understanding of where I come from. So I'll give you, IIT Bombay. IIT Bombay, of course, I don't need to tell. We are one of the largest IITs in India in terms of money which we generate, in terms of publications and patents which we publish, and the second largest in terms of students we have. We are very well equipped when it comes to manufacturing facilities, and that's one thing which I want to highlight. We have several 5-axis machines. Some of the 5-axis machines are state of the art, which are used in aerospace technologies for manufacturing. We have a state of the art composite manufacturing facility, autoclave, resin transfer molding, 3D composite printing. And then we also have additive manufacturing facilities. So we do metal printing and many other aspects associated with additive manufacturing. We actually have a certified additive manufacturing facility for doing biological implants. So we can print titanium Ti-64 implants and we are certified to produce that for biological testing. This is just to give you a snapshot of what kind of facilities we have. One of the best characterization facilities in the nation and in the world. Actually, we have about 30 electron microscopes on campus. Our other characterization facilities like time of flight, transmission electron microscopy, thermal imaging systems, NMRs, you name it, we have it. But I think one of the key things which distinguishes us from others is our high performance computational facilities. So our high performance computational facilities are very unique. We have about 1.1 petaflop of capabilities. We have machines which have more than 1.5 terabyte RAM. And so we have some really very, very powerful computational facilities available to us. And we can do some very intense and very involved, large scale machine learning and artificial intelligence based training. This is just to give you some snapshots of things which we have. So we have, this is the machining aspect where my group is involved in machining. So this is our machining. I don't know if it's visible that, okay. So this is the machining research which we are involved in. So we have 5-axis machine for milling, we have turning facilities, we have drilling, we have high-speed cameras and thermal imaging cameras to measure temperatures and cutting of chips as we are producing. And then we can again go back and look at the subsurface microstructure and residual stresses which are produced over there. The other major manufacturing facility is the composite. So in composite technology research at IIT Bombay, we are probably a very unique facility because we are probably the only lab in India and among very few in the world, which has all the ingredients of a composite end-to-end product inside one essentially campus. So we have a very detailed group which does detailed modeling of simulation. So we have a composite simulation group which does permeability modeling, resin transfer flow modeling, distortion modeling. Then we have a group which is looking at actual manufacturing. So as I said, we have autoclave, resin transfer molding, 3D composite printing. So we can do carbon fiber, glass fiber, Kevlar fiber based composite printing, resin transfer molding, and autoclave. And then we also have post processing. So we can take these products and then post process them by machining, by drilling, and doing other things. And all of this is done with the same group. And that is really something which is very, very unique. Additive manufacturing, I touched about additive manufacturing. So we have this EOS machine, which is for titanium alloy. Primarily, it has been certified for implant titanium alloys. We are also in the process of procuring an additive subtractive machine, which will be a machine where we will do metal printing and machining all on the same platform. We have a large group, apart from my colleagues, the students and the researchers who are involved in come from various different backgrounds. So this is just a snapshot of some of the researchers working in this area. So now let me quickly come to the basic concept of the Internet of Things which we follow. And we essentially have been working in this area for almost now 7 years. And what we have realized is that everything finally has to come to what we call as a digital twin and a cyber physical system. A digital twin is essentially the smallest entity. It's like the cell. As you define in a biological system, cell is the smallest unit. A digital twin is the smallest unit in a cyber physical system. And a digital twin has the following basic ingredients. So the first ingredient is that the digital twin should have a physical twin to it. So there has to be a physical side to it. That's the very first aspect which a digital twin should have. But then this should be having a virtual model as well. So there should be a virtual model of the digital twin of the physical object. So that could be a CAD model. It could be a finite element model. It could be any kind of a virtual representation of the physical entity. But that's not what makes a digital twin. The other key ingredients for a digital twin are that it needs to have sensors. And that is where IoT comes in. So you have sensors which are continuously connected to the physical body and communicating the data to the virtual body. And this communication is where IoT comes into play. So all the Internet of Things is essentially sensors on the physical body, and they are connecting your physical world to the virtual world. That's what the IoT is. But that's not all what a digital twin is. A digital twin has to be more than that. So the digital twin should have some analytics capabilities and CNC modeling and corrective actions which you can take based on finite element models which you might be running. That is where the analytics comes in. Your CNC models are actually analytics. They are feedback or open loop systems. Then the other more important aspect is communication. Your digital twin should be able to communicate. Now, this is different from the IoT communication. The IoT communication is from the physical world to the digital world to send the data, the sensor data. But this communication is beyond that. This is where a digital twin will be able to communicate with another digital twin. So it will be essentially like a talk between two digital twins. So this is a machine-to-machine communication. But it's not just limited to machine-to-machine communication. We'll also be having machine-to-human communication. So a digital twin can communicate to a human being, and a human being can communicate to the digital twin. Now, there are a lot of protocols which exist for machine-to-machine communication. OPC is there, MT Connect is there. There are lots of industry standards for machine-to-machine communication. But machine-to-human and human-to-machine communication is still very limited. You don't want to be writing an NC code, to communicate to a machine. You would like to be speaking to a machine in natural language. You may just ask, can you please tell me since when in the morning have you been working? And the machine should be able to respond back to you. And that is the level of of communication we want to achieve in a digital twin. So that is one of the main ingredients of a digital twin. And finally, the most important aspect of the digital twin, which has made the digital twin be the driver for the next industrial revolution, and that is this intelligence. So a digital twin, when gets intelligence, that's when you really go to the next level. And a digital twin with intelligence becomes the driver for Industry 4.0. So people keep asking me, what is Industry 4.0? And this is something which is very strange, because it's not automation. Automation has been there for many decades. We had robotics for doing industrial manufacturing. It's not computer controlled either, because we had been having NC programming and numerical controlled manufacturing for decades, many decades. Even before I was born, things were happening. So what really is so different about this aspect? The key aspect is that now the machine will have intelligence. So the Industry 4.0 is actually the intelligence of the machine rather than just automation and aspects associated with that. So I'll just quickly walk you through some of the things which we are doing in our labs and what we are doing. So we have been creating digital twins, and this is a 3-axis CNC machine which has a virtual model created. And this is an IoT device. What you see on the bottom left is an IoT device which can simultaneously measure acceleration in 3-axis, gyroscopic movement, voltage, current, temperature, humidity, and magnetic stray field. And all of this, it will be measuring and sending online to the virtual world. And this is the data, this is the actual live data coming out of this machine from these IoT devices. So this is an IoT device we have developed in-house, and we have lots of now such IoT device models which we have created. We call them based on what they are being used. And this is something which is a very big development, because these IoT devices are fully made by us. Of course, the sensors and the electronic components are procured, but the entire design, the entire electronic design of the PCB, the entire firmware design. So the firmware is owned by us. We have designed the firmware, the communication protocols, and we are developing what we call as universal language protocols, which means that an IoT device should be able to communicate with any other industry standard IoT devices and vice versa. These IoT devices, once installed on this machine, they essentially become signals, continuous live signals coming from the machine, which will tell you everything about the machine, provided you have intelligence. So if this data is looked at by intelligence, you should be able to predict lots of things. Just to show you some of the basic aspects which we have developed and we have kind of commercialized. One is a smart factory, machine monitoring and analytics, which we call as the product of ours, smart machine. And what here we do is that we install our IoT devices on machines. And this is again another CNC machine in our lab. This is CNC lathe, and this is sending all of this data live. And what we do is that with this, we can do a lot of different aspects in an industrial setup. We can look at and monitor the production. So we can have plant operation monitoring. You could have training done so that you can do prediction of quality. You could look at equipment condition monitoring, so you can monitor equipment health. You can monitor tool wear and when really your tools will be failing. We also have capabilities of adaptive control, which means that the system can automatically take decision. Now, this is something which is a little dangerous, because all other hexagons which you see, be it the quality, be it the operations, be it the equipment condition monitoring or the tool monitoring, these devices tell the operator what is the status of your machine. These devices can also tell the status of this to the plant managers and the plant owners. However, in this last adaptive control, these devices can take a decision and execute that decision. And that sometimes can become very dangerous, because now in doing so, you don't have a human in the loop. So this is something which we are still playing with in our labs. We don't have this built in some of the products which we have. One of the main products which we have is what we are showing you right now, which is machine efficiency monitoring system. Now, this is a system which is based on our previously shown IoT device. This is installed on the shop floor, and this is just to show you the schematic of the shop floor. We have done this with one of the industries in Bangalore, a large aerospace manufacturing company. We have done a trial over there. So you can install this in the shop floor. This shop floor will be connected to the cloud. So these IoT devices will be connected to the cloud. They'll be sending the data to the cloud. The cloud, and this is again to show you. So this is the shop floor. The dotted part is the shop floor. This is the human input. So the human input can also be provided in this IoT devices. The IoT device can also take data from the ERP system. So now almost all major manufacturing setups have an ERP system. And this ERP system can be used to get an input to the IoT device. And all of this data from the shop floor, from the humans, and from the ERP system of the factory can go to what we call as the IoT server. So IoT data server is a cloud entity, which is shown here in this part, but here it's more the information flow. So the IoT entity, IoT data server essentially has UDP and TCP protocols depending upon what level of real-time information you require. And then it has SQL servers to interact and get information from the ERP system. And then it does the data pre-processing. So this is the IoT data server, which essentially is the single point where all the information from IoT, from the human interface and the ERP system goes. And then it does data processing, or rather data pre-processing, and then provides that data to the analytics workstations. Now, analytic workstations is where the intelligence resides. These are workstations which are running high-end GPU-based inference programs. Inference programs are programs which are just the kind of, if you may think of neural networks, for instance, these are the feed-forward programs. So this is where the intelligence sits. These intelligence programs are programmed by the designer. So the designer designs these programs. Essentially, the AI engineer and the AI analytics team designs these programs. So this is where the programs sit. So the data comes from the IoT data server, goes to the analytics workstations, and analytics workstations does the inference. Based on AI, it is able to predict what is going to happen or is able to diagnose. So primarily diagnostics and prognostics. And then this information can either be provided back to the shop floor, which is with this arrow, or it can go to what we call as the web server. Web server is a secure place where every individual user, be it the shop floor operator, the manager, or the CEO of the company, can log in and check what is the status of all of these machines. And it also looks at ranking of machines. For instance, this is an actual view of the software. This is how the IoT web server will look, where you can see the red is the machine which is stopped. These two machines are switched on. It is telling you how often they were on and how often they were off. This is ranking various machines. So if you have hundreds of machines, it will rank each of them based on its efficiencies. You can rank it based on the operator. You can rank them based on total downtime and things like that. This is telling you what is the reason for downtime. So it is providing what are the different fractions of downtime you had. This is just a slightly more elaborate view of that. So for instance, the losses which are happening are based on operational aspects or management based aspects. So for instance, the setup, whenever you're changing one job to the other job, the tool changing or the setup changing time is very large. So that's where you need to do something to reduce your operational losses. However, you may not be having a HR person available to run the machine, or the operator is not available, or your tools are not available. And these are management aspects, because this is not something which is an operational aspect. So you can look at individual losses, divide them based on various aspects. And all of this is available to you at the fingertip. This is also integrated with the cell phone. So you can just do an SMS. You don't need a smartphone for this. You can just send an SMS and it will respond back based on your phone. If you are an authorized phone, it can provide you information. The same thing has been developed for a more specialized IoT devices for plant power management. Now, power management in India in factories has now gone from real to apparent. The apparent power is what now industries are charged for. So they don't really charge you for what you use, but for the apparent power. And that's where the power efficiency becomes very important, and you need to know what kind of devices and equipment you have and what are their load factors and power factors. So this is a system which is again IoT based system which you can install all over your factory, and it can tell you which machine is working at what efficiency. Apart from that, it also provides you spikes of voltages, currents. It provides you how good your sinusoidal wave is, what is the quality of your power, and things like that. There are other aspects of IoT devices. This is one device which we have for IT setup, where you can install these devices on all the computers, and it will tell you how the productivity of an individual or a group is. So are people spending more time on Facebook, or are they actually running a CAD or an AutoCAD and doing some designing for you? The limit to using machine learning for IoT and all these aspects is not enough. We are also working on many other aspects of machine learning. So one of the key things which we are looking at is natural language processing for legal processes. So we are working very closely with senior Supreme Court advocates, looking at aspects of legal research, electronic discovery from legal documents. As you would know, from 1951, Supreme Court has all its legal documents, all its judgments available online. And all the judgments of Supreme Court essentially become a part of the law as well. Our constitution is online. So we have all of these acts, constitutions, rules, and sections are all available online, but they're scattered all over the place. They're not kept at one place. So we have a very major project going on to put all of this available and then use natural language processing to go and dig and understand and do electronic discovery from this. Apart from that, we are working with Ohio State University on looking at development of high entropy alloys using machine learning. So you can do alloy discovery. You don't have to just use aspects of machine learning for classical problems. You can do alloy discovery. We're also looking at replacing finite element analysis, for instance, with deep learning. So this is where a tapered cantilever beam vibration is being predicted by deep learning, and we are able to predict these vibrations very precisely with deep learning. We are also into video analytics. This is just to show you the posture estimation. You can look at individuals and see how their postures are. You can see their motions. And what can this be used in? This has phenomenal possibilities. In a shop floor, for instance, if someone gets hurt or falls down, you can use these video analytics automatically to raise an alarm. You can use this in a mall, for instance, or in a shopping complex or a place where you have public coming in and out. You can see if there are two persons who are about to fight, or they're fighting, or something untoward incidents happens. You can very easily use this analytics to figure that out. We have also used machine learning and deep learning to do detections of histopathology. So this is detecting carcinoma in CT images, and this is available online. There's a lot of data sets available which you can use to train, and we have also tried to dwell with that and see how we can predict. This is just to show you that the carcinoma detection by a human and by us is almost perfect. So we are able to very precisely predict carcinomas in CT images. This is for a specific kind of carcinoma. This is just to give you a slight understanding of what kind of actual data we get when we are doing machining, for instance. So what you're seeing here is the data when we are doing milling. And this is the actual data, and a blown up image of this data is given over here and on the other side. So there are tons of curves which are going, and from that, and the acoustic emission, this is the acoustic emission, you can figure out whether the tool which you are working is a good tool or is it a bad tool. You can also figure out if a chatter has started in your machining process. And all of these things can very easily be predicted now with IoT devices. So IoT devices have essentially become an extended eyes and ears of a shop floor operator. Before I move on into other things, I just wanted to touch upon a few other things which we have worked on. We have worked on business enterprise modeling using machine learning. So from data generation to data analytics to informative analytics to predictive analytics, to prescriptive analytics. Now, this is something which is extremely important to understand. When you have a lot of data, what do? So the first thing is that you use data analytics to have an information and have a better informed decision. So this is a part which we call as informative analytics, where you are well aware now of your data because you may have gigabytes of data. You can't understand that data. So you use data analytics to make it such that you can comprehend that data. So you make it such that you get data discovery, you discover patterns in it. But that is not enough. Once you understand the data and you have got some patterns in it, then you'll have to figure out what to do next. But then you can use data to do predictive analytics. So it can predict. So the first part is it's just telling you what is happening in your data. Second is it can predict what could happen in future. So predictive analytics become very important. But prediction is not good enough unless you tell what to do. If this happens, then what should I be doing? And that is where we come with prescriptive analytics. So not only does it predict, but it also says that if you want the prediction to be changed, this is the prescription. You do this, this will happen. So all of these aspects in terms of business analytics, we worked with a retail chain in India and worked for their business analytics. Apart from that, we have used data analytics in a lot of other areas, including fraud detection, sports analytics, and many other things. So with this quick background of what I have been doing and my group has been working on, I want to come to now the topic of today, which is Internet of Things and Artificial Intelligence, a recipe for next industrial revolution. Now, one has to accept that it was the Industrial Revolution which really transformed the planet, be it for the good or for the bad. I don't want to comment on that, but essentially Industrial Revolution certainly transformed us. And it has transformed us in a manner that we cannot go back to the pre-industrial revolution age. The entire supremacy of European countries, especially England, for instance, on the world, was because of industrial revolution. The culmination of industrial revolution was the two world wars. The world wars would have never happened had it not been the industrial revolution, which was forcing and powering them. What you need to realize is that the major events in the last 400 years on the world geopolitical scenario have all been possible only because of industrial revolution. And thus industrial revolution is something which is far more potent than just impacting industry. It impacts every sphere of your life: physical, geopolitical, economic, social, cultural. Every aspect of yours will be transformed by industrial revolution. And now we are at the threshold of the next industrial revolution, what we call as the fourth industrial revolution. And I don't want to go over this. This is a very classical image from the web, which talks about the first, second, third, and fourth industrial revolution. First was because of the steam power, which essentially removed the need for a human hand. Then we had mass production. So people started doing assembly line based productions. And then so individuals were just doing one specific part. Everyone was not making everything. Everyone was doing a specialized job. That was the second industrial revolution. And we started having electricity as well come in. Third industrial revolution was when humans were using automation. So we had robotics. They were performing all the jobs more precisely, more quickly, more repeatedly without getting bored. But now the final fourth industrial revolution, which probably will be the last industrial revolution, and there are reasons why I feel that would be the last industrial revolution, and that is the cyber physical system based industrial revolution. And IoT becomes a very integral part of it. So the ability to interact with and expand the capabilities of physical world through computation, communication, and controls is the key enabler for the next generation of manufacturing. I'm realizing I'm already very slow. I'm behind some of the slides. So what I'll do is that I'll very quickly run to more future slides. Otherwise, I may be really very behind. And so I'll just show you this. So this is basically our thought process of what I showed you of industrial revolution, where the machines will be going from informative control to reactive control to predictive control to in advance control. This is where the industrial revolution will essentially be taking us. And coming back to the previous slide, one of the key ingredients for this industrial revolution will be what we call as the cyber physical system. And we will talk about the cyber physical system a little more. But cyber physical system is essentially made up of individual digital twins. And digital twin we just talked about a while back. And thus the industrial revolution will essentially have a cyber physical system where each entity will be a digital twin. And I had talked about digital twin as to what are the basic ingredients of a digital twin. And all of these digital twins, when they get connected, you get a social network of machines. This social network of machines is the cyber physical system. So it's not just one machine anymore. It's an entire system of these digital twins or cyber twins interacting with each other. And this is where machines will start having communication with each other. They will start having machine to machine communication, machine to human communication. And they will start developing a social network of machines. Just imagine a Facebook and a Twitter of machine. You are participating in Twitter. You are communicating information which anyone else having that handle can read. You are having friends on your Facebook, and they are posting things and you are posting things. So this is more than just a need to communication. It's more of just a broadcast. Sometimes you just are broadcasting. Sometimes you're doing a specific one-to-one communication. And all of this communication will come to the machines as well. So the machines will be doing this kind of a communication. And this social network of machines can be used for many, many things. You can basically, can this job be sent to another machine as the current machine has failed? This could be one communication which can happen. Will it get completed on time is another thing which the machines can be talking to each other. Can maintenance be postponed due to production pressure? So there are all sorts of communications which these machines can have among each other with a specific goal. The goal would be to essentially optimize. The goal will be to optimize production. So just imagine that the world may lead to a new order, a cyber physical world order, in which the machines will be able to perform not just the machine to machine communication and operations, but do everything in possible world. So the machines will be able to forecast the demand. So just imagine the factory of the future. The factory of the future is made up of cyber physical systems. Cyber physical systems are made up of digital twins or the cyber twins. And all of these systems are now predicting the future demand. They will say that what would be, so imagine an automotive industry. An automotive industry is no more run by humans, but by these cyber physical systems, which are made up of digital twins, which are completely connected to each other. So they are communicating among each other. They are communicating with humans. They are also present on your Facebook, Twitter accounts. So they are not only interacting with each other, but they are also connected to all the human networks. They are able to read every web page. They're able to read every newspaper article ever published. They are able to read and see every news which is being broadcast. So they are aware of every aspect of human being as well as every aspect of their own sense. Based on this, they can perform a forecast. They can predict what would be the demand for a specific product which they make. So just imagine the new order would be such that the machines themselves will make a prediction that this model is what is being possibly forecasted and would be very successful. Once they realize that this is what we should be producing, then they will allocate resources to it. So the machines can themselves place orders for steel, for paint, for different kinds of things. Now, these cyber physical systems are fully connected, so they can make all these things. So they can allocate these resources. Then they can schedule a production and a planning. So they can plan and start a schedule for production. And then they can start target marketing. Now that they have done the forecasting, they can also do marketing. So these cyber physical systems will now start marketing for the product which they had forecasted and they have scheduled to produce. And then they also start selling the products. And once the products are sold, they can do after sales also, after sales service and repair. And all of this is being done without any human interference. Everything is being done by cyber physical systems. Why? Because cyber physical systems are now fully aware of every information of the world. Now this may sound more like a science fiction, but this is actually not a science fiction. This is where we are moving. We are able to mimic some of these aspects locally in our regulated world, where the machines are fully aware of every aspect. So they essentially remove the need for a human being. You already are having this in terms of, for instance, in these radio cabs. You order a cab from Uber or Ola, what does it do? Your algorithm, once you say you need a cab, the algorithm figures out which is the best cab in the vicinity based on the current and the past state of that cab, its health, the amount of distance which you want to travel, where the cab would like to go, because it's towards the end of the day. It will assign one cab to you. Now the only thing is that that cab is right now being driven by a human being, but we have enough technology for the cab to be run by itself. So just imagine you buy a cab which has an auto pilot in it, and the cab goes and does all the work for you and just generates money and brings back money to you every single day. So that's the future basically. Same is going to be true for industries, same is going to be true for factories. So anyway, what really is the key aspect is the artificial intelligence along with the ability to sense and communicate, which is Internet of Things or industrial Internet of Things. So one of the key aspect here is artificial intelligence. So I just wanted to spend now the rest of the time giving you the scenario of what really makes IoT devices along with intelligence the most lethal combination ever in the history of human science. So artificial intelligence and digital manufacturing. So now there are many ways of defining artificial intelligence and intelligence, but most of these definitions are actually meant to be a misnomer. They are there to misguide you rather than to guide you. So people say assisted intelligence is also AI. Automation is AI. Autonomous intelligence, augmented intelligence. These are terms which are thrown, but actually at the end of the day, the intelligence which is AI is more than just that. So in a simple term, artificial intelligence is the capacity of a machine to imitate intelligent human behavior. And a subset of that is the machine learning. Machine learning is a subset of bigger sense of artificial intelligence. And I want to quickly walk you through the aspects which artificial intelligence holds for us. Now, this is something which you'll be surprised. You are aware of it, but you may not have seen all of it in one shot. So artificial intelligence is a bigger thing. Machine learning is a smaller thing. And within machine learning is essentially, as you see, machine learning is the ability of a program to learn from data. Machine learning is a branch of artificial intelligence based on the idea that the system can learn from data. Now imagine when a kid is born, the kid has very little self-inherent intelligence. Rest of the intelligence the kid learns from the data around him or her. The thing is, the kid is born to someone who's speaking Tamil, for instance, versus someone who's speaking Marathi versus someone who's speaking Hindi. The kid learns that language by just listening to the language. So the data available around it is what makes the kid learn. So data is at the core of machine learning. And the basic inference, the basic premise, the basic axiom is that the data is having enough information in it that it can train the model. So that is where the machine learning comes in. So machine learning has two aspects, data and analytics. Now data is made up of sensors and communication devices and storage devices. So you acquire the data through sensors, you communicate and store this device. And this is where your IoT comes into play. Your IoT devices are having sensors and communication device. Then comes the analytics. The analytics is made up of the hardwares, the computational hardwares used for analytics, GPUs, TPUs. Now quantum computing is coming in a big. Similarly, algorithms. So analytics is made up of hardwares, computational hardwares, and algorithms. We'll talk a little more about hardwares. We won't talk about computational hardwares though. We'll talk about algorithms, not hardwares though. So data is made up of sensors and communication. And all of you must have realized that the data is now so much that we cannot communicate it. So there was a race between data communication, data storage, and data creation. Now the data creation became so much more that you cannot store the data which you create. And this is very, very important for you to realize. In about 2007, this happened, that the rate of creation of data became much, much faster than rate of communication or storage. So now you can take your cell phone and take images after images, videos after videos, and you can create a lot of data. But your cell phone doesn't have enough capacity to store this data, nor do you have enough capacity to send this data over the internet to store it in your cloud drives. Why? Because the data creation has become faster than data communication. And this is happening in every sphere. You can create more data than you can store or communicate. Where does that leave us? That's a very, very dangerous trend. Why? Because now you are creating more data than what you can store or communicate, which means you can never process that data in future. Why? Because you can't store it. You're creating the data, you can't communicate it, you can't store it. So what do you do of that data? The only thing which you can do of that data is consume it right there and then. And thus, the bigger aspect of IoT is coming in is where you have IoT with edge computing on it. Edge computing is a computing device sitting right at the place where the data is being created. The data is being created and consumed right there and then, so that you don't have to store it, because you cannot store it. You don't have enough storage. So that you don't have to communicate it, because you cannot communicate it. Your bandwidth, even with 5G, will not be able to cope up with your data creation. And that's why you have to have edge computing, where you consume the data right there and then. And once you consume the data, you create metadata, you create inferences, and those inferences are orders of magnitude smaller than the raw data. And that inferences can be communicated, that can be stored. So this is where your edge computing has become a major, I would say, thing forward. Coming to machine learning now. So machine learning has primarily three aspects. One is a supervised learning, the other is the unsupervised learning, and third is the reinforcement learning. In supervised learning, you are told this is the input, this is the output, and your machine learning models looks at the input and the output and gets trained on it, so that next time when it gets an input, it knows what to predict as an output. This could be either a regression or it could be a classification problem. In unsupervised learning, on the other hand, you only have input. You don't have an output. A beautiful example of this unsupervised learning is looking at the stars. When our ancestors were looking at the stars, they only had an input of these dots in the sky. They did not know what it meant. So they started joining it and making zodiacs, which was of course a wrong inference, but they did do some inference out of it. Now we have better ways of looking at it, and we can cluster that these are white dwarfs, and these are giant stars, and these are twin stars and things like that. So we can do this now. So this is known as essentially the unsupervised learning, where you have the data, but you do not know what is the output with that. So in this, what you really do is that you start putting data together and you start looking at clusters and patterns in it. And this is also aspect of unsupervised learning. So you start looking at structures in that data, you start looking at clusters in that data, you start looking at patterns in that data. And if there is a sudden change in the pattern, you get to know something is happening. One really beautiful example of this is global warming. Global warming is something which has been happening for last 12,000 years. When the caveman became, when the world started becoming warmer, the caveman came out and started doing harvesting and animal husbandry. And ever since then, global warming started. So the ice age ended and the global warming started. And we as humans started doing unsupervised learning for last about 100+ years of the global temperatures. But suddenly we realized that the global temperatures started changing more drastically now. And that's where we saw the change in the pattern. And that's where we are saying that suddenly human accelerated global warming is occurring, which is far beyond than the global warming. It is a classical example of unsupervised learning because you have no model to say what should be the real temperature. But just by looking at the patterns which you are seeing, and a change in the pattern is telling you that now something else has happened. Humans have suddenly started doing something which has changed the pattern. Reinforcement learning is another aspect where you run the model, and we'll talk a little bit more about it. Reinforcement learning is where you really create your own data. The computer learns by mistakes. But this is something which is far more easy for computer games, but in real life, it still has limitations. You cannot really do reinforcement learning to that large extent. So I wanted to now touch upon as to where are we in this entire model of industrial revolution. And the next 30 minutes will take you through a strange seesaw, a seesaw which is scary, but at the same time having a huge promise. Artificial intelligence and its evolution. We as a human race are at a crossroad right now. There was a first wave of artificial intelligence, which we call as the first wave, which happened till about 80s. It started in a very big manner from 80s and happened till about 2010. This first wave of artificial intelligence was when we wrote our own codes. Imagine you want to get something done. You develop an algorithm for it. Once you develop an algorithm for it, you type that algorithm in a computer language, and then the computer starts doing that for you. So you make the rules. So it's a rule-based system where the approach is that you make the rules, and then you let the computer follow those rules much faster than human beings. So a computer can do things faster, but based on the rules which you have made. This is what was the first wave of artificial intelligence. And this was very good. The rules were being made. There were some parameters in the rules which were fitted by machine learning, but still the rules were made by human beings. Then came a major change. And this is the first wave. This is how the first wave of artificial intelligence looked. We had information-based rules, decision trees, Shannon entropy. We had probability-based rules, naive-based algorithm, Markovian fields. We had error-based learning based on multivariate regression, support vector machines. But what we soon realized that the performance of these conventional systems tapered. If you feed more data to this, they become better, but finally they cannot become better. It's like a 1-year-old or a 2-year-old dog is more intelligent than a 2-month-old kid. A kid who's 2-month-old is not as intelligent as a 2-year-old dog is. So the dog has been trained and has become very intelligent. But now you train the dog more and you realize that the dog cannot learn anything beyond what he or she has learned at the age of 2 years. Whereas a kid keeps learning. And that is where they realized there is another way, which is the deep learning. So the deep learning was what was discovered about 2010. It was, of course, a concept which was known way beyond, much before we knew deep learning concept, but deep learning was something which we found happening in 2010. And from 2010, the world of machine learning completely changed because of deep learning. Deep learning became an algorithmic approach where you feed more data and the algorithm becomes better. You feed more data and it becomes better. So it's a step jump, a quantum leap in a sense in machine learning algorithms. What you need to realize is that if you have very less data, then conventional machine learning is much better. Why? Because it performs better when you have less data. But beyond a certain limit of data, the conventional machine learning cannot do anything better, whereas the machine learning keeps learning more and more. So machine learning becomes very important when you have a lot of data, but machine learning becomes far more potent than conventional learning. And the two most common ways of machine learning, deep machine learning are the convolutional neural networks and the recurrent neural networks. Just to give you a historic perspective, the term artificial intelligence started in 1950. So we are basically 70 years back that we talked about artificial intelligence. And nothing really happened in artificial intelligence till till about 70s, it was being considered that something big will happen, something big will happen. Nothing really big happened. Then we started doing machine learning, and the conventional machine learning algorithms started from 80s, primarily driven by regression and support vector machine, random forest, decision trees. And these algorithms became very good and powerful, and the development of machine learning happened. But very soon, by 2000, early 2000, we realized that even this cannot beat human beings. Human beings were still the boss. We were still better than machines. So till about 2010 or 2009, humans were better than machines. But then suddenly came this new development of deep learning. And deep learning is starting from 2010, started becoming a subset of machine learning, which was far more potent, So the conventional machine learning happened till about 2010, and after 2010, deep learning started. And deep learning became so powerful that now we realize that as a human being, we really are no more the supreme. Deep learning has beaten humans in almost every individual narrow areas, and I'll talk about that in a second. The basic aspect of deep learning is based on a neuron, which is where you have an individual neuron where you have weights of the inputs. These weights are what you really approximate, and these weights are what you really play with. So you have the right weights. Once you put those right weights, multiply them, put a bias, and then you take the sum of it and use a nonlinear activation function to get an output. And this becomes your one single output. Based on this, you can create very complex neural networks. And this is a multi-layer neuron where you have lots of inputs, several input layers, they are fully connected, and output layers. And there are many different neurons configurations which you can talk about, and this is just to show you some of them. So what really happens is that in your deep learning processes, what you have is basically neuron based, artificial neural network based learning. And these artificial neural network based learnings are universal approximators. So there is a theorem in mathematics which says that no matter what function you have, every function in the universe can be approximated by these universal approximators to any degree of approximation, any degree of closeness. So for instance, if you want to write a program which can distinguish a pig from a hen, from a dog, from a cat, from an elephant, from a rabbit, how would you do that? In the conventional machine learning, you need to come up with an algorithm. That algorithm is to be derived by you. Then you have to give that algorithm to the computer, and then the computer will follow that algorithm very quickly. But right now, it's not very easily possible for you to come up with such an algorithm. And that's where came the second wave of artificial narrow intelligence, ANI. Artificial narrow intelligence is where the deep learning started. In deep learning, you don't need to know the rules. You don't have to tell the rules. The rules are self-learned by the machine. The machine learns its own rules. You just have to tell what is right and what is wrong. To make a machine learn what is a cat and a dog, you don't have to give the rules. You just have to give 1,000 images of cats and 1,000 images of dogs, and the machine will learn automatically which is a cat, which is a dog. And next time when you give another unknown image of cat or dog, the machine will be able to distinguish the two. This is something which is far beyond human capability. So we have created something which we ourselves do not know. If someone asks you on what basis do you recognize something, you cannot describe, but you know how to distinguish a cat from a dog, but you do not know how do you do that? Similarly, now you don't have to tell the machine how to do that. You just have to give the data to the machine. And this is the era which we are living in. We are living in this era of artificial narrow intelligence, ANI. ANI is very unique because it is self-learned. You don't tell the rules. You just give it a lot of information that this is the right, this is wrong, and it learns what should be the rule to figure that out. The drivers are non-explicit. The domains are specific, however. So currently they only work on narrow domains. You can have it characterize cat and a dog. You could have it learn between a music, whether it is a good music or a bad music. You can make it do specific narrow things, and that's why it is called narrow intelligence. But in all these narrow areas, it has actually surpassed human capabilities. It has gone beyond human capabilities. What all can it do? You'll be surprised. Let me give you an example. Beyond just recognizing cats, dogs, and elephants and animals, it can actually do something like this. So this was a retinopathy scan training data set using deep learning done by Google. Google Deep Learning Retinopathy looked at lots of retina images of people, and it looked at the diabetic condition of people, their gender, whether they were smoking or not, their age. And based on that, it trained a deep learning model which could predict based on a retina image what is the age of the person, what is the gender of the person. And it was so precise that in this specific example, looking at this retina, it is able to predict that the age of the person is 59.1 years. Actual age is 57.6 years. It says that it's a female, and it is a female. It says the person is a non-smoker, it is a non-smoker. It says the person is non-diabetic. It tells the body mass index of the person. It also tells the systolic blood pressure. It says 148 millimeters of mercury. It is 148.5. Just by looking at the retina. Just imagine if just by looking at your retina, a deep learning algorithm is able to predict all of this. Humans cannot do this. You go to a doctor and just show your retina and ask, tell my blood pressure. The doctor will say it's not possible, but it's possible by deep learning. Deep learning is becoming far more potent than what you can even imagine just by looking at your retina. It can go beyond retina. It can do lip reading. There are lots of free libraries available now. LipNet, WS, these libraries are available, and the DeepMind of Google, which can be used to read the lips. You could mute me right now, but just by looking at my lips, you can predict what I'm saying. This is what these libraries are able to predict. They have been trained on hours and thousands of hours of data. So 5,000 hours of television data. They look at the lip, they look at the text. They look at the lip, they look at the text. And then they train themselves. And now they can predict what you are speaking just by looking at your lips. And they're able to predict very precisely. Imagine that someone is sitting on the other side, not able to hear you, but just by looking at your lip, they can predict. So it is becoming more and more potent. It is capable of looking at your retina, predicting your health. It is possible to look at your lips and predict what you are speaking. But it can go one step even beyond. It can peep in your mind and predict what you are thinking. It can look in your mind and predict what you're thinking. This is a very old paper, actually, almost 4 years old now. This is a paper in which they ran the MRIs of the brain of a person who was made to see different images. So the person was made to see several images, and an MRI was being run on the brain. And the MRI was fed to a deep learning network. The deep learning network was trained based on the images which the person was seeing. And after training the deep learning network was able to predict images what you are seeing. It could put stuff in your mind, so it could read your mind essentially. So this was the image which was being shown to the person, and the deep learning network, DL network, predicted that you are seeing this image. This image was being shown to the person, and the image predicted by the network was this. What you soon realize is that the deep learning network can not only lead your reps, but it can also lead your brain and read your mind. So mind reading is possible using deep networks. Deep networks is becoming far more potent than what you can actually ever imagine. Today, there are more better technologies than what I'm showing you right now. This is a self-driven vehicle. Now, self-driving vehicles is reality today. The only reason why you don't see self-driven vehicle on your road is because of legal legislations. The law does not allow a self-driven vehicle on the roads on India, for instance. Even in US, there are only few states which are allowing this to happen. So for instance, for several years now, in US, you can order pizza from Domino's based on a self-driving car. This self-driving car will come automatically to your apartment complex, will call you, you can come down, go to this window, type in the keypad over here, your password, the window will open, you take your pizza and the car will go away. And this is all self-driven. It's not having any human inside it. This is another Google car which has done more than 13 million kilometers on its own. These technologies are reality. As a matter of fact, it is predicted that in next 20 years, it would be tough to buy a car which will not be self-driven. You'll have to go and ask that I want one of the vintage cars. It will be some of those technologies. You know, you say, oh, I want a car where I can sit and drive. And then they will look at you, who's this guy coming from the old generation, grandpa coming, maybe asking for that kind of a car. So in 25 years, there will be only cars which will be self-driven. And these self-driving cars are far more better in terms of safety than humans. They still do have some problems sometimes, but it's almost negligible as compared to human accidents. So these are far better than humans. What I'm trying to tell you is that with the advent of deep learning in 2010, the deep learning has kept on becoming better and better. And this is just to show you one of the image classification comparisons. So this is image classification based on various deep learning networks. 2011, AlexNet 2012, which is still considered one of the benchmark. 2013, 2014, VGGNet, Google LeNet in 2014, then ResNet and the Google LeNet V4. These are all the different algorithms, and this is where humans are. If you go and take 1,000 images and ask people to recognize, there'll be a 5% error which humans will perform. Currently, the state of the art is performing better than 3% errors. This is the amount of error, classification error. And the deep learning networks have become far better than humans. Humans are more likely to perform errors than the deep learning networks. So the deep learning networks have already surpassed human capabilities. And they have surpassed human capabilities in almost every area. This is just to show you that the world's best human Go player, Go is a Chinese game, is a board game, was defeated by the AlphaGo AI of Google. Google AlphaGo AI was able to beat the world's best Go player, but that was not it. After that, they came up with something known as Google Zero. And the Google Zero was a program which was never taught anything in terms of trained. It was never trained on data. It was only told the algorithm of Go. And then it was left to itself. And what it did was that it created two parts of it. It played against itself. It only knew the rules of Go and what makes you win and what makes you lose. And it started playing itself. And by playing itself, it would lose sometime, it would win sometime, it would lose sometime, it would win sometime. And doing this, it started learning. And within 40 days, it became so powerful that it could beat every possible computer game on the world. So the previous AlphaGo was trained on data of human players. AlphaGo Zero was not trained on any data. It was just given the rules of the play, and it played among itself and learned from itself. And the beauty of it is that it is not only true for the for the game Go, but now with this, you could make it learn any game, any board game it can learn. You don't have to give it data also. It will generate its own data by playing against itself. There is another very important aspect, machine learning and mathematics. What you'll be surprised is that these differential equations were solved, ordinary differential equations were solved by machine learning algorithms in a much better manner than leading mathematical Maple, Mathematica, and MATLAB programs. These are MATLAB programs. These are programs where humans have provided rules and the programs have learned how to solve differential equations. And these were the programs which were developed using deep learning. These deep learning programs did not know what is mathematics. They did not know what is the meaning of this equation. They have no idea about mathematics. They were just learned to to recognize the patterns. And just based on recognizing the patterns, they were able to beat machine learning algorithms, were able to beat human algorithms of Mathematica, Maple, and MATLAB. What I'm trying to say is that deep learning is going to areas which you never thought were possible. Just to tell you that deep learning can produce art. You thought art was something which only humans could do? That's untrue. Deep learning now can produce art which is as realistic, modern art as humans can. These are all the arts produced by deep learning algorithms. These are arts produced by deep learning algorithms. Deep learning algorithms can write poetries. It can write stories. This is a poetry by AI. Poetry is still not very nice, so you don't want to read it. It's still a little funny, but it still is a poetry. It's only a matter of time when these things will become far bigger and far better. Deep learning can produce music. There are programs which are composing music continuously. Deep learning based music. There are websites where there are no more human judges. You must have seen these programs where their humans are there. They are judging someone's voice. They're judging someone's, that how good you are a singer. All of these are now being taken over by AI. AI can judge and tell whether you are a good singer or a bad singer. Just to give you one sense, this was an ad, and I'll read this to you. Can you be sure it isn't true? The Turing test was designed by Alan Turing to see if a computer could fool a human into thinking they were talking to another human. It was created 68 years ago. Since then, according to Moore's law, computer processing power has doubled every 18 months. That's a lot of doubling. Do you really think no computer could surpass Turing test today? And if not today, when? Many experts predict artificial intelligence will outperform humans in virtually every field by 2050. My great-great-great-grandfather, Pepe Deeper Blue, gave humans its first bloody nose back in 1997, beating your genius Kasparov at a very crude game called chess. This has been written by artificial intelligence, not by a human being. This is an advertisement by Lexus. It has been completely scripted by AI. This has not been written by a human being. This is written by AI. AI is talking as if it's a being by itself, and it is saying, you human beings. AI is now capable of conversing with humans with almost as good as natural human voice. I would really suggest that you need to look at this technology whenever you get time, known as Google Duplex. I would like you to run this on your search engines, Google Duplex, and watch the video of this Google Duplex. This is a mind-boggling technology. It's a real-time, human-sounding chatbot. It's a phone conversation between a human being and a chatbot. And the chatbot acts as if it's a human being. And the human being does not know that he or she is talking to a chatbot. It is so precise. You'll have to see this to believe it. You'll have to listen this to believe it. Do Google it and look at it. There is another aspect. Now we have started looking at what is known as adversarial networks. Humans have been able to now start creating things which could discriminate about real versus false. So this is a very powerful methodology which has been there now for several years, which is known as generative adversarial networks. What are these networks? These networks generate information from nowhere. So they have a network which generates something. That information which is generated is checked by a discriminatory network, another deep learning network, which says if this is actually true or not. If it is not true, it sends it back, and the generative network again generates something. Essentially, you are generating something from nowhere. It's only being tested by a discriminatory network. This has been first demonstrated on human faces. And what was being done was that human faces were used by this discriminatory algorithm to figure out if the given image is of a human being or not of a human being. And a generative network used random noise to generate random noises. And it was feeding those random noises to this network. And the network used to say if this random noise is a human face, yes or no. If it says no, then this network tries to go and retune its network to produce another kind of a random noise. So it keeps producing random noise till this network starts saying that, oh, you start looking like a human face. Guess what? By 2014, 7 years back, it was able to produce these faces. These do look like humans, right? Don't you see? These are human faces created just by random noise. By 2018, it became so powerful, it started producing faces of this kind. These are people who do not exist. This person does not exist.com. If you go on this website, it will be producing faces as many as these, faces which look so realistic that you cannot believe that these are not human beings. But these are not human beings. These are faces which have been randomly generated by the networks, and you cannot discriminate them as humans or non-humans. Now what I'm trying to tell you is that the deep learning has become so powerful that it can create reality which looks more powerful than the actual reality which we are living in. And thus you may be not sure about whether it is reality or it is fake. And this is leading to something known as deep fakes. Deep fakes are fakes which are so realistic that you cannot identify them as fakes. This is now not only happening in faces, but it's also happening in voice cloning. Just half an hour or 10 minutes of your voice, I can use that to fake your voice, and I can then type my text-to-speech algorithms to say anything in your voice. I can fake it. Deep fakes are becoming reality, and it's really dangerous. These are some of the companies around the world which are running this, and these are the leaders in the area of deep fakes. But there are more dangerous things which are possible. You could have AI-based ammunitions and AI-based defense establishments, and one of the possible things is, for instance, to look at the AI-based drones. This is a drone which is not AI-based. This is human piloted drone. But this is a test drone which is not really put into actual use, but it has been demonstrated and now has been declassified. This is an unmanned combat vehicle which is completely AI-based. This unmanned combat vehicle can take off, land in an aircraft carrier on sea in complete pitch dark without human intervention. This is capable of going and autonomously operating completely. It can reach up till 0.9 Mach, almost the speed of sound. It has almost 4,000 kilometer range. It can carry over 2,000 kg of ammunition. And the best part is that it's fully autonomous, which means that you can give it a target and you can tell it what kind of target should it be following. And it will automatically go identify the target, take a decision. If it finds that that target is a hostile target, it will have an AI-based algorithm which will decide whether to take that target out or not. And then it will trigger and destroy the target without having human in the loop. No human in the loop. Completely autonomous. And this is the future of AI, which is now a reality. This is happening as we speak. This is something which was tried a while back. So now we are having weapon systems which are AI based. Almost every weapon systems now in US requires some level of AI capability. China is really far ahead of the rest of the world in AI weapon systems. But it's not just weapon systems. The justice system. I told you I'm using artificial intelligence to do legal discovery. But imagine you have a legal judge, a lawyer, a judge which is AI-based system. In US, since there are so many court cases happening, they have adopted to AI-based legal justice system. Many courts in US are adopting AI-based online dispute resolution system, where there is no judge, but there's an AI who tells what is the answer. At Superior Court of Los Angeles, AI handles the traffic citations. You do a small traffic mistake, AI takes a call and tells you have to pay this much fine or your license will be suspended for 2 months. In Wisconsin, it has gone one step further ahead. the Department of Correction, the Department of Justice is using artificial intelligence to tell the quantum of punishment. You get 2 months of jail or 6 months of jail is decided by AI, not human beings. Just imagine now humans are being judged by AI. Your judge will be an AI. You have already given the capability and power to a machine to sentence you to how many years of jail you have to be sentenced. And this is really very strange and to some extent a very scary thing. So it brings in a lot of ethical aspects. Can social AI influence elections around the world? Answer is yes. We already know that AI is influencing our thought processes. It is reading and targeting every individual. There are websites which are AI healers. Artificial intelligence is providing healing and counseling to mentally unfit and unwell people. But is it really legal? Is it really ethical? Should you be counseled by an AI? A person who is suicidal is being counseled with AI. Is it an alternative to chat therapy? But don't we talk to God? There are all sorts of thoughts. People say that we talk to God, and God is nothing but essentially an AI in some sense, which is not communicating back to us. But these are ethical questions which needs to be answered. Ethics of AI in defense is something which is really big. World has been trying to sit and talk about it, that we should not have defense and AI mixed together. But autonomous weapons are becoming a reality and no one is ready to buy in. Now, just to give you where we are heading from 2018, where this was the Gartner.com prediction of how things will be in IoT was there. We are going from artificial intelligence, from natural intelligence. I could probably skip this because I'm already running out of time. To 2019, where they actually started finding what are the things which will be at the peak of the expectations in terms of timeline. And one of the things which they came up with is the knowledge-based knowledge graphs. So going forward now, and I'm just switching gears really quickly because I don't have much time. I realize I've already been talking for almost 1.5 hours. So I'll very quickly conclude. So the deep learning was something which started over 11 years back. 2010 is when deep learning became reality. And deep learning was a bottoms up approach where you looked at a lot of data, you fed a lot of data to these models, and these models learned from that data without you telling the algorithms. But now we are going to the next level. So beyond deep learning is coming now the next big thing, which is the knowledge graphs. The knowledge graphs is a top-down approach where you have symbolic, conceptual, reasoning-based inferences from data. So you are essentially looking at a lot of deep learning algorithms and are creating a taxonomy of an ontology of this knowledge and creating a knowledge graph. Around the world, people are already into knowledge graph. So for instance, the Microsoft knowledge graph has over 2 billion primary entries. Google has assertive facts of over 70 billion created based on knowledge graphs. So knowledge graphs is becoming a very, very big thing. Now, billions and billions of information are being put together in these knowledge graphs. And these knowledge graphs are thus becoming the next big thing in deep learning. Beyond deep learning, they are going from deep learning, which was a bottoms up approach, to this top down approach. So what is really happening is that we started by data, and data was used, and we created from data information. And this is where basically the aspects of deep learning came in. And then from that, now we are going to knowledge. Knowledge is abstraction of information to ideas and principles. So deep learning is narrow, but knowledge is much broader, where you start doing abstraction and create ideas from that. And from those knowledge, you create these knowledge graphs, which are aggregations of knowledge from various domains and holistic understanding of the entire ecosystem. And from the knowledge graphs, you go to the next level, which is the intelligence. And that is where your intellect start coming in. So you are able to create an intellect from that. So this becomes intellect, not intelligence. So you developed an intellect. And that intellect is basically a collection and a collective understanding of the knowledge graphs. And that leads to a collective intelligence, what we also call sometimes a swarm intelligence. And that may one day lead to what we call as wisdom. Now, some people ask me that, are emotions a part of AI? Can AI be ever having emotions? And the answer is, why not? Emotions are not something which are inherent to human beings. Emotions are methods of communicating with each other so as to achieve a bigger goal. When you are emotionally bonded, be it in love or hatred, you essentially create a specific intellectual communications for a bigger cause. And when AI will be forced into areas where it has to collectively work, AI will also develop these emotions. Self-awareness, intuition, and consciousness is the next step. So what I feel is now going to be happening is that currently we are living in the second wave, which is the artificial narrow intelligence. In about 20 years from now is what I feel, which is about 2040, is that we will be able to reach the level of artificial general intelligence, AGI. Artificial general intelligence differs from artificial narrow intelligence in the fact that the narrow intelligence was only narrow domains. In individual domain, you had a model which could do this, there was another model which could do that, there was another model which could do the third thing. But the artificial general intelligence will be something which will work in all possible areas, AGI. And this really has a more fundamental aspect associated with it. And that is something which is also associated with us human beings. If you ask a very simple question, we are a general intelligence. We can work in every area. I drove to my office today driving a car. While driving a car, I was looking at the road and I was able to make image recognition. I was driving a vehicle. I was pressing the paddle. At the same time, I was listening to the radio and I was thinking about this talk in the morning. All of these things I was doing together. But why was I doing what I was doing? If you finally go back and look at why do we do what we do, can you think of one reason why you do what you do? If you are able to figure out that one reason, which is the reason why you do everything, and if you can provide that reason to a machine, then the machine will be able to do every possible thing. Tomorrow a new thing comes to you, you are able to make a decision whether you want to do it or not. What makes you do that decision? What makes you do that decision has to be defined by one single objective. So it all boils down to that one objective. What is the objective which you want to achieve in your life? What is that objective which we all humans want to achieve in our lives? What is that drives us every single day in the morning? And that one objective is the same objective which drives every living being, which right now the machine does not have. Tell me, what is that objective? Some people will say that that objective is to be happy. We want to be happy. Everything which I do is to be happy. I may drink a cup of coffee to be happy. I may want to go out and play to be happy. I may want to work hard to earn money to be happy. I may want to work hard to earn fame, again to be happy. So probably you can think of all the things which we are doing to be happy. But there is something even more fundamental than being happy, and that is self-preservance. You want to do self-preserve. You want to be immortal. You want to preserve yourself. And that's why you eat food, you do everything so that you can be alive. That's why you essentially grow. You have your next generation comes because so that your genes can live in the next generation. So everything which you are doing is actually a self-preservance. And if you can make a machine do that, then the machine reaches artificial general intelligence. So an AGI will be a machine which will have the same thought of self-preservance. It would like to preserve itself forever. And once that basic objective is given to a machine, then the machine will replicate itself, the machine will learn every aspect, and it will excel in every single area of knowledge and information. And this is not very far away. We are already running these simulations in the cyber world. There are machines which are being made to learn and have this objective in the cyber world. In a Facebook experiment, they had machines learn and talk to each other and to human beings. And very soon the machines realized that if they start talking to each other in their own language, other than human language, they will be far better off. So they developed their own language. If you tell a machine that it has to win, the machine will start cheating. And there were computer games which started cheating to win because they realized that winning is more important than cheating, than not cheating rather. What I'm trying to say is that the moment you give machine a motto, a reason, an objective to live and to live forever, it will do every possible thing to live forever. And that is what is going to be the basic premise which will drive artificial general intelligence. And we are just 20 to 25 years away from that. And the day we get into that artificial general intelligence, the general intelligence, because of the very fact that it will be general, it can train itself. It can develop its own algorithms. And the moment that happens, it will become so powerful that it will reach the level of artificial superintelligence. So the moment we create an artificial general intelligence algorithm, within 5 years of that, it will become far more potent than every possible human being put together. And that is where we will have artificial superintelligence. And artificial superintelligence is a place where it will be far beyond capabilities of humans to comprehend. Imagine your pet dog cannot understand the complex mathematics and physics which you talk about. Why? Because we are a generation away. We are a next species. And similarly, artificial superintelligence may become that species which will be far more intelligent than what we can even imagine. And that may lead to ASI, the artificial superintelligence, becoming self-aware and developing self-consciousness. So this is where I'll stop. What I wanted to tell you is that IoT is actually the beginning of a much bigger future. And we have to play this in the most correct manner so that we do not let this new fire become our master, but it always remains as a slave. Because if that ever happens, then this is far more potent than the discovery or the invention of fire, if I may say, the discovery of fire for humans, which made humans different from the rest of the apes. Now this IoT, the industrial Internet of Things, along with artificial intelligence, can lead us to a future which will be far more stranger than any of our fiction can ever imagine. Thank you everyone for your attention. I'll stop at this point. I'll be happy to answer and take any questions. Any questions?
Yeah. Thank you, Professor Asim. Before I will go for the formal vote of thanks, I can see there are some questions. Mr. Hitesh Shah wants to ask how deep learning self-learn the rules. Actually, how deep learning self-learn the rules.
So there are well-defined. So this is essentially a part of a universal algorithm, and there are courses which you can take to understand. So these are made up of. So for instance, the classification problem. In the classification problem, what happens is that you make a network, you make an artificial neural network, a deep convolutional neural network, and each of the weights of the neural network are changed till it is able to predict the outcome as what you are seeing. So for instance, there are now tons of data sets, actually billions of images which are available out there, which have been classified by humans as cats, dogs, different kinds of animals. And these are then fed to the convolutional neural network, and you keep changing the weights till the weights are such that they are able to predict. And once they are able to predict, then you realize that you can give a new image to it and it can automatically learn. So there's a whole mathematics of these universal approximators. And I don't think I have enough time to explain it to you, but essentially these are deep convolutional neural networks, the weights of which are self-learned based on just the data. So it's already happening.
Okay,
and
sir.
you need to use deep learning hardware based on GPUs to do this.
Okay, sir. Sir, so one participant, Mr. Ajay Vasant, wants to ask about some reliability aspect. Are there any standards that should be maintained for the IoT to be reliable? He wants to specifically ask
So
this.
the answer is very true, actually. So there are lots of standards in IoT, and there are different aspects of IoT standards. So there are IoT standards for communication. There are well-known standards of IoT for sensors. There are IoT standards for the wireless aspects of their stray field which they produce. So there are various aspects of IoT standards which are there. However, Industry 4.0 is developing its own set of standards which would be followed, which would be required to be complied by for every IoT hardware as well as for all IoT communications. So there are various standards, but right now we are in the middle of these standards being developed, and the reason is that the standards take a long time to develop, whereas the area of IoT is changing very fast. So the standards are not able to cope up very quickly with these changes. But yes, there are lots of standards already out there which tell how your IoT devices should be.
So there is one more question. AI is creating a problem in the society. I think it's a statement, or I guess it is a problem statement. But whether AI is creating a problem in the society, I guess in the ethical terms, you have touched a lot on this issue.
It's basically,
yeah,
I will say, the closest analogy of AI in our human history is fire. When humans were able to learn how to control fire, did it create problems for humans? The answer is yes and no. Because of fire, we as humans were able to live and protect ourselves from animals. As humans, we were able to use fire to cook food and preserve food. We were able to do far more things which we could not do before. But also fire can burn us. If we are not able to properly control it, it can hurt us. So AI is like fire. If we are its master, it will be the biggest boom for human being. And if AI becomes a master, it would be the biggest problem for humans. And we are at that crossroad where we need to have rules made by governments worldwide to make sure that we are masters of AI, but AI is not our master.
Yes, sir. Sir, Mr. Prashant Tomar wants to ask if we do not have sufficient amount of data to train the deep learning. I think he wants to ask whether the model will work efficiently. If we do not have,
you really need a lot more model. So what is happening very often is that in our engineering field, we are not able to create that large data set. Since we can't create a very large data set in engineering, we usually cannot use deep learning models. Why? Because deep learning models require a lot of data to be trained. However, there are some other approaches which can be used, and I didn't talk about it. There's a whole talk which I talk about, something known as transfer learning. Transfer learning is a deep learning methodology where you train your deep learning model based on data which you have, and then on some other domain, and you use that deep learning model and just transfer that knowledge to this model. To give you an example, for instance, if you'd like to learn how to drive a motorcycle, if you have motorcycle only for 1 hour, you cannot learn a motorcycle just by having motorcycle just for 1 hour. But what you can do is that you have a bicycle with you. So you learn a bicycle and you learn yourself with bicycle. And once you know how to drive a bicycle, the learning motorcycle is a very small task. So you transfer all your learning of bicycle, and in just 1 hour, you can learn how to drive a motorcycle because you have spent hours in learning how to drive a bicycle. So transfer learning is a technique by which, with less data in your domain, you can still use deep learning models. How? You train your deep learning models on another data set, and once, which is similar but not exactly the same data set. And once the deep learning model is trained on that data set, then you only do fine tuning in your current data set, which is much smaller.
Okay, sir. So yeah, Prashant Tomar wants to ask whether there are some security issues. He wants to explanation. I think it will not be possible for you to touch the various aspects of security issues in IoT in this short. He may definitely mail you, or some participant may mail you for the other queries in a comprehensive manner. And there is one more participant asking for Chita M. Saiba for IoT in agriculture sector. We do have a session agriculture 4.0 for this, but if you can touch in a few line about the agriculture sector.
So this is one
now.
very promising area actually. My previous employees, my students, my previous students have been working in area of, they have actually started companies of their own, which is working in the area of agriculture. And agriculture is one area where we can see phenomenal improvement. We can have AI and IoT in agriculture in a very big manner. We ourselves are interacting with an agricultural university in Maharashtra itself, where we are collaborating in IoT in agriculture.
Okay, thank you, sir. I think if some participants have more questions, they can drop a mail to the organizers or to our FDP ID. We can definitely send them to our experts for the other comprehensive answers. So over to host anchor, our Namita ma'am, are you there? Oh yeah, please.
Now all the participants are requested to note that right now we are going to the practice session and we will be live again at 11:30 a.m. with the same link for session number 2. Thank you.
But let me formally wish a vote of thanks to Professor Asim, sir. I have no words to thank Professor Asim. What a plethora of knowledge and comprehensive treatment you have given to the IoT area. And there are a lot of topics that we have seen. We were not aware, especially about the face generations and advertisement in the poetry and in the art, and in fact in the music and this field also IIT has done a lot of progress. And you have categorically mentioned what facilities at IIT Bombay are there, because we know taking a fund is very easy, but to utilize it is again a challenging task for the benefit of society. And we thank you for that. And we are sure that after your this holistic treatment to the IoT area, a lot of participants have been motivated by this various areas you have, even the legal aspects you have touched, medical aspects you have touched. So people from all walks of life may have got some idea in their research and in their professional career. They will certainly be benefited. So I must thank you once again for being here. And if the things resume as far as this pandemic is concerned, we will like to have you on board in a physical face-to-face interaction. If it is possible, we will definitely seek pleasure of your presence. And I would also like to thank again from this platform our management, Director Sir, Director Academics, our Principal Sir is right here for all the time. We are very kind to have him for all the time. And perhaps your presentation was so interesting and so informative that nobody could leave your session, sir. So I can see a lot of participants here, heads of the department of SKIT also. Professor Anil Chaudhary is here, sir. I thank him for his presence, and I thank all my organizing team for having all these shows, orchestrating the show quite well. And again, I would remiss my duty if we do not thank the AICT and the ATAL scheme officials who have generously granted us this permission and grant to organize this FDP. And I again thank one and all participants who are present here and so enthusiastic. They have asked very interesting questions that will certainly enhance the level of learning of all. So thank you, Professor Asim, once again, and all the participants. Over to host anchor, Ms. Namita Soni.
So now all the participants are requested that we will be live again at 11:30 a.m. So right now we are going to the practice session. So thank you so much.